Yes, hey LeetCode family, welcome back. Now let's solve certain word search. And yeah, again the question is pretty straightforward. You'll be given a board containing some random letters, and you have to search if the given word exists in the board. Yeah. See, if A B C C E D exists, then you have to return true, and A B C C E D it exists, so return true. And the thing is, you can move only in the four cardinal directions: up, down, right, left, or north, east, southwest. You can't move diagonally. Keep note of that. And again, yeah, if you know what is backtracking, then yeah, this is mainly a recursion problem which generally uses the depth first search. First try to implement it using BFS, but yeah, the code obviously failed because I was not doing it properly. And yeah, now what to do is, yeah, you have to start iterating from each word of the board, and if the specific word becomes equal to the first letter of the word, then you can just start a depth first search from there, and you will and you will continue it till the index of the word which you are checking currently is existing in the board and in the correct position. And yes, I'll tell you why breadth first search will not work. First, let me just code up the DFS solution. And yes, what you have to do, it's given that grid is of m cross n, so you can't directly use grid two times. Yes, if it, consider you're in A, consider over here. If you see an S, then you have to start the depth first search, only because since the given word is yes, when you are here, you have to check if all the neighbors consists of the letter E. That's why you have to start the first search whenever you encounter the first letter of the word. So if becomes equal to word at the position 0, then you have to start the depth first search, and if it returns true, then you can directly return true, and if it did not return to anywhere, then you could never reach your solution, and you will return false. Now let's fill it out. What you will need, the current positions, and you will need a visited set which has not been declared yet, so you have to call it set over here, and the current index of the word in which you are checking, so it is 0. And if this becomes true, and if the total recursion of this becomes equal to true, then you have to return true. Yeah, so let me just use those elements over here. So you're taking I, J, and visited set, and the current ID of the word. And yeah, now first you have to check for inbounds, because you can obviously not check for out of bounds. So one trick which you can use is, you can check for inbounds, and if it returns true, then return false. I hope you understood how it works. Just return the not of inbounds check, which will tell you if the current index is out of bounds, and whenever it goes out of bounds, you have to return false. So the inbounds check is so yeah, this is the inbound checks for the ith coordinate, and you have to search for the yth coordinate also. Yep, and yeah, if this condition is true, that means that the position is inbounds. So now, yeah, and since you're doing not, it will tell that okay, whenever it goes out of bounds, it will return true, and when it goes out of bounds, you can obviously not find the solution. Or else, if the current index which you're checking, for example, when you're checking E, and when you check for A and F, and if they're not equal, then again you can't proceed. So yeah, it's not grid, and everywhere it's board. Just replace with board. And position J, if it does not become equal to the current word which you are checking at IDX index, that means you're going wrong. Or if the current index which you are checking exists in visited, in other words, if the given word is AB, then you will never be able to get that over here. But if you don't add the previous check index, then what will happen is it will go to A, it will go to B, it will go back to A and B, and it will return true, and you don't want that. And yeah, if you already visited that node, it's visited, yeah, then return false. And yeah, now how will you get to know if you have reached the end of the word? Yeah, that is when the idx becomes equal to the length of the word. So idx becomes equal to, yeah, this is for zero based indexing. Then what you will do, you add the current word to the visited array as visited set. Yes, after adding, yeah, check for its neighbors. So you now check if the current index is in bounds. You can actually copy this part and just replace it properly. I with dx and j with dy. If it is in bounds and the current index which you are checking is not in visited, yeah, again you don't want to keep on looping on the same word. If it is not in visited, then you have to run the depth first search on it. So I is dx and j is dy, and you are in the visited set with idx plus 1. I hope you understood why you are going to the next sentence. Yeah, and yeah, if this returns true, then you have to return true, because yeah, to proceed to the next iteration, or else what you have to do is you have to backtrack and you have to remove the current node which you are checking from the consideration. I'll tell you why you have to do that now. Yeah, the main thing why BFS won't work here is because you can't backtrack. That is the main issue why BFS fails. And it should exist in visited. I forgot to add the in. And yeah, I have not defined directions itself, so yes, this is again the 4 cardinal directions. Yes, and don't forget to define everything. Yes, it's working. Yeah. Now I will tell you why we have to backtrack. We just print, yeah, and why the BFS solution won't work. And I learned this the hard way. And make it print, not a print or something. So check this one. Yeah, the entire thing is returning true because the first letter itself is the one. Yeah. Now just consider it had one more one like L. Yeah. Now I will tell. Imagine the L was not there. Now I will tell why we have to backtrack. Because yeah, coding up the entire BFS solution will again take a lot of time and it won't obviously work. Yes, okay. Now look at it. So first we have to check for A, B, C, E. We will check for A. A exits. this is not B, so you'll go forward with B, and then you'll go to C. And the thing is, again, now what will happen is there are two E's, and only while going to the right E you will reach the answer, but when you go to the bottom E you will never reach the answer. And what will happen is, when you see that you won't reach the answer from bottom E, in BFS what you will do is, yeah, you will mark that node as unreachable and you will continue. So it will go to E, it will go to S, and then when it tries to reach this E, it will tell, yeah, this has already been visited, so you can't visit it again. And suddenly what will happen is, it will go down this to this E, and it will then return false, telling that the word was never found. But actually the word goes like this in the snake order: A B C E S E F S A D E E. And that's the thing why BFS won't work. You have to check the entire word for each depth first search solution. That's why you are checking the entire search over here, and only if that search returns true you will return true, and if it does not return true, then yeah, you will not return false, because if you return false, that will again stop the search prematurely, and you don't want that. Yeah, so that's why BFS won't work. You have to go with BFS. Let me just submit it once. Yeah, remember to remove the print statements and all. And yes, it works, and since it is a recursive depth first search solution with tag tracking, it will obviously be very, what do you tell, very time consuming. And so yeah, that's it for today.